In this video, we are going to cover the Kubernetes setup for multi-master cluster setup. So far, what we set up, we did only one master uh, in Kubernetes cluster. But in production environment, it is recommended to use multi-master. So in case of failure, your multi-master cluster will sustain. So to set up the multi-master cluster, first of all, we need to understand some basic concepts. So I will draw a diagram. Think like this is your Kubernetes multi-master cluster and you have 3 master nodes. And think like you have whatever number of worker node, but right now I'm just talking about master nodes. So master 1, so we have 3 master nodes. So API server, the scheduler, the controller manager, and etcd will run on all these 3 master nodes. The etcd is a database and it will run as only on one master node, but one of the master node will be responsible to take care of etcd. The rest of 2 master node will just use the etcd as just like you can say the read only. So this will be an election in between this master node who will be responsible to take care of etcd. So that is the reason we can use the odd number of master node in multi-master cluster setup. So we can set up 1 master node or 3 or 5 or 7 or 9. So that when the election will happen, so the one decision will be available to decide where our who will act as the read write. So now we have 3 master nodes, and these 3 master nodes have their API server. All 3 master node server are up and running with API server. So when as an end user, I have to communicate with this API. So I can either communicate with this one, or I can communicate with this master node, or I can communicate with this master node. So in my kubeconfig file, I can define the IP of one of the master node. But what happens if any of the master node failed? And if I set up this master node IP in my kubeconfig, then I need to change the IP of master node in my kubeconfig. So this is not the way to use in production environment when the kubeconfig API connectivity with one master node when you are going to make multi-master setup. So there should be a load balancer on top of these master nodes. This load balancer, we will use the HAProxy. HAProxy is a load balancer that can take the request from end user, okay, and then can route the traffic to different master nodes. So the API request will come to HAProxy, and then HAProxy will will send the request to any of the available master node. If one master node failed, HAProxy will not send request to that master. Okay, so this was the case for the API. Now the end user who want to access the application that is hosted inside the Kubernetes cluster. How they will access the application? So, when we set up the ingress controller, so ingress controller actually create two node ports, one for port 80 and one for 443. And I also explained you that we can connect some load balancer in front of those node ports to connect the external user with port 80 and 443. So for example, this user, suppose we can say this is the Kubernetes admin PC. And this is the end user. And end user want to access the application. So when the end user will access the application, so we cannot, same like the API server, we cannot route the port 80 and 443 directly on the master node. So what we will do, we will set up the HAProxy to receive the port 80 request and port 443 request. Let me just write here 80 and 443. So these two requests will come from end user. And in HAProxy, we have to define if request come for port 80, request come for port 443, then route the traffic to master node for to that specific node port that is exposed for 80 and 443. Similarly, for this master on this master node, similarly on this master node. Okay, so HAProxy knows all the master nodes with their node port, where the port 80 will be routed. And similarly, if we have worker nodes, so HAProxy should also know, should also have the rule to route the node port, the traffic to the node port for the port 80 and 443. So with this way, our HAProxy will work. And one more thing we will do with this HAProxy, we will use this HAProxy as an internet gateway for all our master and worker nodes. So this is also possible that we could have a different gateway, but in our lab, I will set up HAProxy as an internet gateway too. So this machine will perform two functionalities for internet access, for the netting, and for load balancing HAProxy. So this machine, the HAProxy machine, will have two network interfaces. One will be connected to the external network, from where the kube admin and end users will send the request. On that IP, the interface, the end user will send the request for Kubernetes administration and application access. And the second interface will be connected to the network that is connected with the whole cluster. So it's mean we have two networks. One is LAN and one is WAN. We can say LAN is the Kubernetes network and WAN is the external connectivity of the Kubernetes by HAProxy. So for this reason, what I did, I set up a Red Hat Enterprise Linux machine. CentOS 7 is end of life, and for this reason, to set up the HAProxy, I don't want to use Ubuntu. So I use Red Hat Enterprise Linux 9.4 And I set up this machine with two network interfaces. One is connected to my physical network, uh, 192.168.18.30, and another interface I created, 10.10.10.1. So this 10.10.10.1 will be the gateway of all my Kubernetes cluster, master node and worker node. And all my master node and worker node will have IP 10.10.10 series. So first of all, I need to set up the host name of this machine. I can say HAProxy LB. Let me just log out, log in back. Name is displayed now. So HAProxy is ready. Let me check the internet is working. Okay, internet is working fine. So this is a Red Hat Enterprise Linux. I can use CentOS, but CentOS actually after the right now the CentOS project is almost ending. So that's why it's good idea to use Red Hat Enterprise Linux. They are providing if you create a developer account in Red Hat Cloud. So they will give you 16 machine free of cost with the Red Hat 16 subscription with the developer account. So I will use the subscription uh, to connect with my Red Hat subscription so that I can take the leverage of repositories and pull down the packages from Red Hat repository. In CentOS, by default, the repositories are enabled. So just trying to connect with the Red Hat repository. Okay, so it is registered. So now if I do DNF, yum command also you can use either DNF or yum. Repo list. So these two base OS and app stream are enabled. So what I will do, I will enable. First of all, I will install some basic packages. So Vim I am going to install because this is a minimal install Linux, bash completion for the auto completion on the second and third level, net tools for the netstat related utilities. HAProxy we will use as a load balance. So I have to yum DNF install. packages are installed. So now I have to configure my HAProxy. So HAProxy config file is under the etc HAProxy directory, haproxy.cfg. This is the default HAProxy config file. Okay. And there are some sample rules to define. So what I am going to do, I am going to clean up this whole file, and I will put my own HAProxy configuration in the in this configuration. So let me explain you what are these settings. This is the max connection setting, the log level, uh, and the user and group responsible to run this, the service of the proxy. Uh, these are some timeout related settings. If some service is not available, it will try to retry 3 times. This is the stats. It will show you a page that will show you the status of what services, mean what load balancing we are going to do. I mean the API and the ingress port 80 and 443 on the node port is active or down or not. With this dashboard will show you the real time status of HAProxy. This is rule for the Cube API. So here we defined the front end and back end. So the load balancing rule will work with the front end and back end rule policies. So here is a front end. This is a name I defined for the front end. So A8S API front end, and it will bind for port 6443, and colon 6443 mean from any IP. It's just like this column mean any IP can connect with 6443. And the default backend mean where to route the receive request on 6443. It will be routed to K8S API backend. And backend is defined here. Backend K8S API backend. And it is a TCP protocol, balance the source, mean distribute the request among these 3 servers. So I will set up these 3 master nodes with these names. These names can be any name, but I just define that the meaningful name. It's not mandatory that your master node name should be like this. This is just a representation, but this IP should be like the IP of my master node 1. This will be master node 2. This is master node 3, having port 6443. So 6443 will be running on all master node, and this check availability of this port. If this port is down, it will remove this entry from this list. Similarly, this rule is for the API. So whenever on the public interface on HAProxy 6443 request will come, it will be distributed among these 3 nodes. For the port 80 request that will come for the application from the end user, it will be routed to backend HTTP ingress default. So I routed these 2 worker nodes. So you can also add here a worker node and master node. So let me just copy paste, and 201 is my master node 1, 202 is master node 203 master node 3, and here I will put the name Okay, so now the port 80 request will be distributed among the whole cluster. So the cluster will be containing on 3 master node, 2 worker nodes. So whatever number of worker nodes you have, you can define here. Similarly, the port 80 request will come, but this thing I did wrong. So this port, this will not be port 80, this will be something port node port. So node port, just like node port is 3001, 3001. I'm just setting here the random node port, but when I will set up multi-master cluster under this API server, then I will change that actual port, or I can hard code this port in my ingress control. So I just defined this port, this node port will work as a port 80. And here for the HTTPS request, 443 will be routed to these uh, 5 servers. Let me just copy paste here. So master node 1, so just like 3000. Two port, his node port will be used for HTTPS. So this will show us that the status of all these 3 nodes, either this port is up or not. So right now I'm just going to for port 40, 80 and 443. I set up the rule and 6443. So if there is any other port you want to expose from your API, from your cluster, you can add another rule of front with the front end and back end, defining the source port and the destination port. So 6443, I use the actual port, 6443 for the API. Let me just save this and systemctl start HAProxy. So there is an error. I believe I have some mistake. So to check the mistake, you can see think I did some mistake in Cube API front end, API back end, Cube. Okay, this is good. HTTP ingress backend. HTTPS ingress front end and backend. HTTPS ingress. It's good. What is the reason? Let me check the status. Front end API cannot be bind socket permission denied. There is some mistake. I think I'm just looking to, yeah, permission denied, cannot bind socket 6443. Yes, I think this is due to my SE Linux. SE Linux is enabled. So, when the SE Linux is enabled in Red Hat, so you must have to define the port in SE Linux. So for HAProxy, let me just set enforce 0, disabled, for permissive, set to permissive, restart. Yes, it is working now. So the issue was with the with the SE Linux. So you must have to disable the SE Linux, or you need to configure the SE Linux for the expose ports, because now if you look into your netstat, you can see the port 6443, port 443 and 80, and 9000 is for the monitoring. So these four ports are exposed by HAProxy. So you must have to define in your SE Linux ports uh, for HAProxy. That the HAProxy will use this port. So I don't want to configure the SE Linux right now. That is a different topic. I will just disable. I will just disable this SE Linux and I will reboot it later on. But right now I just set it to settings for 0. If you want to understand this SE Linux ports we can enable, you can contact me on my email. Okay, so now our SE Linux, this HAProxy is up and running. So, but one thing is still there, firewall. So firewall is still up. So I will disable firewall D and I will stop the firewall D. And I will enable the net filter IP tables rule to enable the netting. I will not use the firewall D. So right now firewall is disabled and port 9000 is up. And if I browse this IP 9000/stats, so you can see the HAProxy variant. It is showing, this is a dashboard that is showing us all the information about HAProxy traffic that is managed by this HAProxy. So right now, Kube API front end, Kube API backend. So what is this front end? I need to check. Ingress front end, ingress backend. Okay, so this is the front end. Yes, so this is the front end, mean how many requests is coming on the front end and where it is distributing the request. So this is the front end I showed you. It's a limit we defined. Status is open, but right now all the backend associated with this front end to receive the request on port 8F6443, all the master nodes are down. So I defined the master node only for the API, but and for the HTTP request, I defined master node and worker nodes. All are down. And for the port 443, all master node and worker nodes are down. Because right now my cluster is not up and running. So when I will spin up my cluster, so we will see here, this will be turned into green. As the HAProxy will see that the API is getting up and the node port, whatever we define for 80 and 443 is getting up on these nodes, it will be green. So this dashboard is very good to show you what is the status of your whole cluster, what worker nodes are up or down for which port, and how much load is distributing among the cluster by HAProxy. So we did our first step. And the another thing I want to do, I want to set up the IP table for to set up the netting. So by default, to install the IP table, we need to install NF tables. It is by default installed. So NF tables is net filter tables are packages used to uh, take care all the rules that you will write to to take care whatever IP tables rules you are going to write. So status, it is active. And okay. So this is the, if I run IP tables hyphen capital L, there is no rule. So this rule I wrote to enable the netting on my WAN interface. So my WAN interface is ENS 160. So I will define here 160. So now to view all the rules, I can use this command. So it is showing me -t net, whatever netting rule I added here. So all the source, any source will be netted to any destination. I just wrote a very simple IP table rule for the masquerading by this interface. So now this machine will act as uh, a router, as a netting gateway. And whenever the traffic, any machine will send request on this interface, it will be forward those requests to this interface for the netting. So the internet is available on this interface. That's why it will make sure that the internet is available. So this is done for HAProxy part. In the next sessions for the multi-master cluster, we will set up 3 master nodes and we will install the Kubernetes cluster from scratch, and we will define 3 master node. And there is a minor difference to do this activity. The document that I uploaded in the Git for the installation of the single master node cluster setup, I also mentioned in that document for the multi-master cluster setup, but I will show you in that session.